Welcome to qnawire.
All right, so we are going to be methylating 8 species here, and they're asked to predict the major monoalkylation products you would expect to obtain from the reaction with chloromethane and aluminum chloride. So we're going to go in order here. I'm going to be giving some commentary as we go because I don't necessarily think that this question is very well worded, only because of some exceptions about Friedel-Crafts that I think are being ignored here. But so we're going to assume that all of these reactions happen, and we're just going to go solely based off directing effects, right? So they want the major product, so we're going to give them the major product. So let's start with the bromination product, right? So bromine is an ortho para director, although deactivating. And you may remember that deactivated rings are not going to undergo Friedel-Crafts, but these slightly deactivated rings, the halogenated rings, are okay. But anything less deactivated than that tends to not undergo Friedel-Crafts. Also, remember that Friedel-Crafts has a tendency to poly-substitute. So because the question said we're going to have a monoalkylated product, we're going to ignore that as well. So we're going to probably get a mixture of ortho and para bromotoluene here. Probably favoring the para substituent, the para substitution, just from the bromine being a pretty large atom. It's going to disfavor the ortho positions due to some steric interaction there. So I know from the textbook said that anilines tends to not react by Friedel-Crafts because there's a amino group that is able to undergo protonation. And that's true, but there's also another reason, which is that the nitrogen tends to bind to metals, right? So atoms with lone pairs will form coordination. You don't know about this yet, maybe, but they'll form coordination. They'll coordinate to the metal, which will inhibit the aluminum to be inactivated, to be available to activate the alkyl chloride for Friedel-Crafts to make the carbocation. So phenols are also less active in that regard, but the amino groups being stronger bases are going to inhibit the aluminum. So that's why the textbook says you can't deactivated rings and amino compounds do not undergo Friedel-Crafts. But we're going to pretend that this is fine. Phenols tend to be okay, but I think the yields are just pretty low of these compounds, but we're going to ignore all of that, right? So anyway, so you have two ortho and para directing groups. So the effects of the the effects of the phenol are probably going to override the effects of the bromine because it's a stronger activator. So you have a tendency to want to put that at either of these ortho positions to the methoxy or the phenol, or para to the phenol. And being that bromine is an ortho para director, I would imagine you're going to get some contribution. So I'm going to say there are going to be two major products here. Probably you'll probably get some mixture. So you'll get a methyl group there, but you'll also form this compound, metabromine, and then ortho. I'm going to make some room here. I'm going to move E over, and I'll move F over, because you're probably also going to get this one. Right, so there's two ortho positions. Probably disfavors that one because you're shoving a methyl group that's relatively sterically encumbering to the ortho positions right between those two substituents. So you're probably you might not want to draw this one, but it's still directed there by both of the groups on the ring. So you can't discount it. I would say this generally doesn't go Friedel-Crafts alkylation because it is an amino group, which the textbook did say tends to have a hard time undergoing Friedel-Crafts, but we're going to listen to the question and say what products would I expect here. I wouldn't expect any products, but if it were going to be to react, it's going to be ortho para directed by the amino group, but the para position is already taken up by the chloride, so I'm going to draw two products here. Really, it's one product because of symmetry, but it's probably going to go ortho to the amino group. And then you could put it on the other side, but it's the same compound. If you just rotate, you'll have that position. You'll have that in the other position as well. I'm not going to say the methyl, the ortho position to the chlorines are going to be favored at all, because the amino group is so much more activating than the chlorine is deactivating. It's a much stronger director. So I'll say that's the major product. We have a tri-substituted ring here, right? So you have the nitro group that wants to put this meta, but you have both of the chlorines that want to put it ortho to the chlorines and maybe para, which is the same position here. So because the nitro group, both of the chlorines are directing it to this position, I'll say the major product is probably going to be between the chlorines, even though that might be relatively sterically encumbering. Why can't... There we go. So I'll put it right there. You might also see some... you might see some ortho to one chlorine, para to the other, still meta to the nitro group. So I'll include that in my answer as well. You have a similar situation here with this dichlorophenol. You have the ortho. You want to follow the electronics of the phenol group, so it's going to want to put this ortho to the phenol. Even though it's meta to both of the chlorines, it's a stronger director, so that's most likely going to be a major product here. Pretend there's an H. Pretend I have enough room to write my H. So your methyl group's going to go there. Chlorine. And then it's going to want to put it para to the hydroxyl group, the phenol group, but it's there's already a chlorine there. So I'll say that's the sole major product. And then you have this benzaldehyde, this benzoic acid, which I'm going to say is not going to undergo Friedel-Crafts alkylation normally because it's a deactivated ring, but for the sake of the question. So I'm going to say no product, but if it were going to be a product, it's going to go meta, because those carbonyl groups are meta directors. So I'll put the methyl group there, even though I really doubt this is going to happen. It's too deactivated. Just two left. Also, same with this. It is a deactivated ring. I just want to check something really quick. I would say even that nitro compound probably isn't going to react by Friedel-Crafts because you have three deactivating groups. So, but if it were going to react, that's probably where it would go, right? So, you have this methyl sulfonic acid, which honestly was probably not going to undergo any type of methylation here. But if it was, the meta directing strong deactivation from that sulfane, I can never say this, the sulfonic acid group, is going to want to put this meta, which is also ortho to this ortho directing methyl group. But again, it's too deactivated of a ring, in my opinion. So, and then finally, you have this dibromotoluene, which is probably going to, they're all ortho para directors. So, but it's probably going to follow the methyl group being the stronger ortho para director. So it's most likely going to make these two compounds. So you'll have another methyl group that is ortho to the first methyl group. And then you'll have a compound that is para to that methyl group. So you'll make a dibromoxylene in a way. Right, so the question is predict the major products. Even though I answered all the questions, I would probably say that this aniline probably wouldn't react because the amino group is going to not be compatible with the aluminum chloride. That's something that was talked about in your textbook. I would say this part D is probably too deactivated to react. Definitely F is too deactivated to react. And G is too deactivated to react. But I still drew the answer if it were an activated enough ring. where would the substituents guide that methyl group during the alkylation reaction?